Hi guys, this is Mr. Urrego, and today we're gonna graph quadratic functions in vertex form. Okay, so the first thing we need to know is that my general function for vertex form is y equals a x minus h to the second power plus k. Okay, right now I'm gonna solve this. I'm gonna graph this example. Y equals x minus 4 squared minus 3. Okay, now it's called vertex form because I can get my vertex right away from, alright, let me erase that. I can get my vertex right away from my function. Okay, what's my vertex? My vertex is h comma k. Okay, so let's identify what's h and what's k. If you notice, on the general form, I have an a in front of the parentheses. So a will be any number in front of the parentheses. The h is inside the parentheses with the x. The k is on the outside. Okay? So, therefore, if there's no number in front of the parentheses, right here, if there's no number here, then you have a 1. There's a invisible 1 right there. So, a equals to 1. Now, the h is the opposite of whatever you have inside the parentheses. The h is the opposite of whatever you have inside. So this is negative, then the h will be positive. And the k is whatever's after the parentheses. In this case is negative 3. Okay? So from here, I can get my h comma k, which is my vertex. So my vertex is equal to 4 comma negative 3. And that's my first step. Now I need to plot that vertex on my coordinate plane. Now that I have my vertex, I'm going to plot it on the coordinate plane, which I have right now. And the vertex is 4 comma negative 3. 4 comma negative 3, so I'm going to go in x4 and I go down negative 3. So it's around here, a little bit higher, I think. Around there. So that's your vertex, okay? Through your vertex, you're going to draw your axis of symmetry, which is a vertical line that goes through your vertex. In this case, it's going through 4, okay? Again, this is the axis of symmetry. Okay, axis of symmetry. Once I have my vertex and my axis of symmetry, now we just need more points to draw my parabola, which is the quadratic function. Okay, so I like to find more points on either side. On either side, this is my axis of symmetry. I need to make it table values either to the left side or to the right side. It doesn't matter which one I go. Okay, because I want to do symmetry to the other side. In my case, I want to make a table values on the left side. So I'm going to choose values right next to the axis of symmetry. If the axis of symmetry is 4, then I choose 3 and 2 and maybe 1. Okay, so let's make it table values. The table values, like I said, we're going to use 3, 2, and 1 because those are the values that are next to the axis of symmetry. Now, when I choose 3, I need to plug this 3 into the original equation. This y equals x minus 4 to the second power minus 3. So I'm going to place that 3 in here. Alright, let me show you. So I put 3 when the y's values for negative 2, I put the values here, negative 2, 1, and I went ahead and I solved for x equals 1 and it gave me 6. Okay, now these values are every single point. Every pair or pair is a point on my coordinate plane. Which I mean, what I'm saying is that the first one is 3, negative 2, the next one is 2, comma 1, the next is 1, comma 6. Okay, so I'm gonna go ahead and plot those values. Let me see if I can erase this. Okay, negative 6. Negative 6, okay? I'm going to plot those values on my coordinate plane. So let's start with the first one, 3 comma negative 2. 3 comma negative 2. 3 comma negative 2. Around here is 3 comma negative 2. The next one is 2, 1. Around there, okay? The next one will be 1. That's a positive 6. I made a mistake right here. It's a positive 6, okay? So it's 1 comma 6. So I go 1 and 6. And those are my values. Now what I want to do now is do symmetry to the other side. I have all these values on my left side. I want to do symmetry to the right side. Okay, so this point right now, it's 1 away from the axis of symmetry. So what I'm going to do is I'm going to go from my axis to the symmetry to the other side 1. Okay, and they will give me this point. Now the next one is 2 away from the axis of symmetry. So I'll go 2 away, and let's write the 2 away, and this would be the 3 away. Okay, so 2 away from the axis of symmetry, around here. The next one is on the top, the 1, 6. So I'm going to go ahead and do symmetry to the other side, and it will give me this point is 3 away from the axis of symmetry. So I go from my axis of symmetry to the other side 3 away, and the point is around here. Once I have my points, now I just need to draw the parabola, the curve. Remember, this is a curve, so you gotta go and draw a curve through it, and that's your parabola. Okay, and that's it. Thank you very much for watching. Bye. Let me just fix that because it didn't go through all the points. There you go. It should be going through your points, and I'm making a mess. Alright, through the mess, curve right here, curve, and it goes up again. Okay, thank you. So, I have the 3 right here, and I have the 2. Okay, so my original function is y equals x minus 4 squared minus 3. Now, I'm going to rewrite it, but whatever I have the x, I'm going to put x equals 3. I'm going to replace it by 3. Okay? And then I'm going to follow the order operations. So I just replace on this step. Now I'm going to come over here and it says, alright, y equals 3 minus 4 is negative 1. I rewrite the square minus 3. Y equals negative 1 to the second power is positive 1. Okay? Minus 3 is going to give me negative 2. So I'm going to put that negative 2 on my table of values. I'll be there in a minute. Let's replace x equals 2. Again, the original function, y equals, instead of the x, I replace it by 2, minus 4 squared minus 3. 2 minus 4 is negative 2. Now, order operations, I do exponents first. So negative 2 squared is going to give me 4. And minus 3 will give me 1. So again, x3, when x equals 3 is negative 2, and when x is 2, y is equals to 1.